So today we will go to discuss about the VI characteristics or the output characteristics of a transistor. So in this way, on this regard, you see, basically we have two terminals in a transistor. One is input terminal, that is the between base and emitter, and the output terminal is between the output is taken across the collector and ground, or collector to emitter. Okay, so now you know, as this is a NPN or PNP transistor, so the input junction is a PN junction, like a PN junction diode. Okay, so the input characteristics, that is the that can be defined between the input voltage and input current. So input current is IB, input voltage is VB. So that is nothing but just very similar to a PN junction, normal PN junction diode, or VI characteristics of a normal PN junction diode, that we have discussed earlier in the VI characteristics of a PN junction diode. So our today's discussion is to discuss about the output characteristics, that is the output voltage, that means the collector to emitter voltage with respect to the collector current, okay, IC. Okay, so this is the arrangement that we have done upon a transistor. So this tab, basically this controls the value of IB. There are three multimeters here, you can easily observe. So this one shows you the IB or the base current, and this one shows you the IC or the collector current, and this multimeter shows you the VCE or the output voltage. So first of all, we will fix the value of IB. So this IB can be fixed by this knob, this tab, and by fixing the value of IB, we will vary the value of VCE. So by this tab, we will vary the value of VCE. So at the same time, accordingly, the value of IC will also vary. So, but basically, in general, if we will discuss, so first of all, we will make this IB constant at like 5 microampere or 10 microampere, and with this, I will change the value of this VCE by this knob, and I will observe what is the change in the value of IC or collector current. So let us first in this way. So first this value, as I am fixing it at 5. So this is 5 microampere. IV has been fixed at 5 microampere. So this is IV. I have fixed at it 5 microampere, and this is the reading. So we have made the reading here. So IV has been I have taken here just 15. So you can take 5 microampere, 10 microampere, 15 microampere, 20 microampere. So for this person has taken 15 microampere, but I have fixed it at 5 microampere. So now I will change the value of this VC. So you see the value of VCE, so it's now 1, at 1 it is 1.5, 0.91, so then, I'm sorry, it has been changed, so just make it. So this is 5, so this is 5.2, 5 equal to 5, so 0.5, 0.05, you can observe that 0.1 at this is 3, 0.2, 1 or 1.5, it is 3.5, so 0.3, 4.2, or 0.6, you can 4.4, 0.7, 0.7, it is 4.4, 0.8, 9, it's almost constant. You can easily observe, though I am increasing the value of VCE from now it is constant at 0.44. So this has been recorded, and similarly, if I now change the value of IB, so IB now I will change it to, suppose, let's say 10 microampere. Okay, so it's 10 microampere. We'll hold it at 10 microampere. Now I'll again reset the value to 0, 0, and you can now I'll increase the value of just say VC. So it's 0.1, 0.2, slightly it is increasing, and you can also observe the value of IC is also increasing. It's 2 microampere. This is in microampere. Okay, so 0.2, 0.3, 0.3, 0.04. You can see that this value of IC also is increasing. This is, I'm sorry, 0.1, 0.16. You see, you have to make it or increase it very slowly, because 0.2 is 1.3, 0.3, almost constant 1.34. So though I am increasing the value of VCE to 8 volt, so again the value of IC remains constant. So you can easily observe that here it is the graph. So you can see this is the value of VC and this is the value of IC. So though I am increasing the value of VC, so initially it is slightly increasing. So after some time you can easily observe that the value remains almost constant. So this is what called as your ohmic region, and this is what called as your saturation region. You can easily observe that after this the value of IC is almost constant. Okay. So if I are still increasing the value of BC, so after this you will enter into the breakdown region that has not been shown here. So there are actually two regions. There is ohmic region and another one is your constant current region. So this is what called a saturation region, or in this region the transistor acts like a constant current source. Though the output voltage is increased, but the output current remains constant. So this is for one value of IB. If I draw the another value of for another value of IB, so it can be drawn like this. Okay, it can be drawn like this. Okay, so in this way. Okay, this is for my 5, this is for 10. In this way you can draw it. Okay, so that's all for today. Thank you very much. Thank you.